This is section 256, and we're going to solve inequalities. And in this lesson, we're going to solve inequalities. So if I wanted to solve and graph this solution, it's an inequality. It looks very similar to an equation. We actually want to treat it like an equation. We're going to pretend that this is an equal sign that when we go through and do it. Because if it's an equal sign, that's just a quadratic equation. We know how to find quadratic equations. So we're going to find the solution to that. And so I can factor it, a times c, factors that add to b, you get 3 and negative 1. So you can go through and you can factor that, which means each solution is going to be negative 3 and positive 1 because I can set them equal to 0 and solve. Now if that was an equal sign, we would be done. We solved it. But it's an inequality. So now we have to take an extra step. And that extra step is to see that region, the region in which makes the statement true. And so then we take our values and we place it on a number line. The inequality informs us if it's open or closed circle. So since it says equal to, I know I'm going to put a closed circle. And now I can go through and I can test each region, true or false. So I want to pick a value to the left of negative 3, between negative 3 and 1, and greater than 1. So if I plugged in negative 4 and simplified that, I get 5 is greater than or equal to 0. That's true. So because it's true, I'm going to write a little true statement there. Now I can test the next value. So what's a value between negative 3 and 1? So you have negative 2, you have 0, you have negative 1, and then 0. So I'm just going to plug in 0 because that seems easy. And so if I plug in 0, I get negative 3 is greater than 0. That's false. And then a value on the other side, so like 2. So I can pick 2, 3, 4, 5. And so if I plug in 2 and simplify, I get, again, 5 is greater than or equal to 0, which is true. You shade the sides or the regions that are true. That represents your solution. So that right there is the solution. That right there is the answer. And so your answer, you could say, is going to be from negative infinity to negative 3, union from 1 to infinity. That right there is our answer. Now, in the previous lesson, I said compare it to 0. Now, why did I compare it to 0? So let's kind of think about some logic that goes behind this. If instead I wanted to think of it as true and false, what if I just thought about the number itself? Is my number positive or 0? And so if I plugged in negative 4 again, you get a positive number. We got 5. And so I'm just going to write a positive there. If I plugged in the 0 again, I got a negative number. I got negative 3. So I could put a negative there. And then if I plugged in 2, I got a positive number. I got 5. So I can put a positive number there. Now, why did I do that? Because this actually represents logic. It says greater than or equal to 0. So if I think about it on a number line, what kind of numbers are greater than or equal to 0? Those are our positive numbers, which means all of your positive numbers are true. And so that becomes your answer. So we converted the true and false statement into this positive or negative statement. Now, right now, because we don't have very many solutions, it doesn't really matter if you do true or false, if you do positive or negative. It doesn't really matter at the moment. Just know that the solution will be the same. It might be a good idea to practice the positive and negative part because as we get more solutions and our equations get more complicated, it's going to be easier to look at the positive and negatives. But you can always fall back on the true or false if you forgot. Now, what we did here, just kind of visually, is we said which parts of our graph are greater than 0. And so those parts of the graph are going to be greater than 0. And so that was our solution, negative infinity to negative 3, union 1 to infinity. So let's look at another one here. So it's quadratic. I want it to compare to 0, so I'll subtract 4x on both sides. Again, factor a times c, 4 factors of 4 that add to -4 would be -2 and -2, and so my solution is going to be 2. I only have one solution this time, so we can put it on our number line. It's equal to, so it's closed circle, and now I need to test each region. I can do the positive and negative part, and I'll show both, or we can just do the true and false. So if I plugged in 1, or 0, or -1, right? You could plug in any of these values here. I plugged in 0, I got false. Now I can test a value on the other side, like 3 or 4 or 5. Again, I plugged it in, I got 1 is less than or equal to 0, that's also false. So my answer is actually only this 2. Because it's the only thing that's shaded in or closed circle. What I'm saying is that 2 is the only value that's less than or equal to 0. Now what if I did the positive and negatives? If I plugged in 0 again, I got 4, that's positive. If I plugged in 3, that's 1, which is positive. If I look at this statement right here, numbers that are less than 0, so if we think of our number line here, 0, numbers that are less than or equal to 0 are my negative numbers. And so your negative numbers are now true, and then your positive numbers are going to be false. Well, that's why they're false, because those are my positive numbers. And so the only value that I had is true. Now, if we look at the graph visually, I'm asking where are all my values less than or equal to 2? Well, it just so happens that the only value that equals 0 in this case is going to be 2. Let's look at this case right here. X squared plus 1 is less than 0. Now, if I try and solve it, so remember we pretend it's an equal sign, subtract 1, square root both sides, I get imaginary numbers. That means there are no real solutions, which means there are no values that I can put on my number line. And so there's nothing there. That means the entire number line is one big giant region. It's not being split into 2 at all. And so I can pick any value and test it, so I'll plug in 0. So if I plug in 0, I get 0 squared plus 1 is less than 0, 1 is less than 0, that's false. That means the entire region is false. Or if I wanted to think of it positive numbers, right? So this is positive. This is saying less than 0. What kind of numbers are less than 0? Those are negative numbers. None of these numbers are all negative. And let's take a look at our graph. If we notice it, all the values are positive. We're looking for, where is my graph? Negative. And there were no negative values here. Now, what does it look like if we have an absolute value function? This is probably the only case where comparing it to 0 doesn't really give us any benefit, but we're still going to pretend that it's an equal sign, and we get rid of the absolute value with that plus or minus, so that means we have 2 equations. I just distributed the negative on the second one. So if I solve for each one, I get x equals 5 minus 4, divide, and you're going to get positive 3. So those are my solutions. So now we're going to place those on a number line. They're both open circle because there's no equal to. And now we can go through and test true or false. So if I plugged in 2 minus 4, is that less than 1? So I get absolute value of negative 2. Is 2 less than 1? That is false. So now I'll plug in a value in between, like 4. So now I'm going to get 4 minus 4. Is that less than 1? Is 0 less than 1? That's true. And if I plugged in 6, 6 less than 4, is that less than 1? I get 2 is less than 1. That is false. Now we just got to be careful. Remember, it's absolute value. So anything inside the absolute value becomes positive. So we shade the value that's true. And so my answer is going to be 3 to 5. So what did we learn today? We learned how to solve inequalities, and remember to visualize it. We're thinking about where is it above or below that value. And in most equations, we're trying to compare it to 0 So if it's above 0, we're looking for positive numbers. If it's below 0, we're looking for negative numbers. So this does conclude our lesson. If you have any other questions, please leave them in the comments.